So therefore, after going to sleep, alright, you also have to wake it up. Alright, so in order to wake it up, alright, normally because when you put it to sleep, you want to wake it up so that you want to change things, right? So likewise from your computer, if you normally you sleep your computer or hibernate your computer, you also want to turn back your computer on, right? So therefore there also still a few stuff in order to wake up from whatever thing that is sleeping. Alright. So therefore for microcontroller can be woken up by either internal or external signals. Alright. So the first one is when the voltage on an input pin changes logical value. Alright, you just need to memorize lah. I also don't know what the hell are they trying to say. Alright. I would think that the logical value is talking about the 0 and 1. Alright, so normally when you sleep, you often have a 0. Alright, so if happen that if there is a certain signal that is coming in, alright, then from 0 it will change to 1. Okay, and therefore this one will actually wake it up, the system. Alright, so therefore if the signal, the binary from 0 will change to 1, and therefore it will wake the system up, things like that. Okay, I may be wrong, but just take it. And nonetheless, there will be an internal oscillator. That is something that is besides the main counter. Just now we say there is a main clock oscillator. Alright, so there is an internal one that is besides the main system that it will own self count itself. So when it reaches a certain time out, you will, after a known delay, alright, then it will actually wake it up. Alright, so it allows wake up on a set date and time using a real time clock. Alright, so I would think that you can also condition the microcontroller to a certain timing so that a long time, alright, then you wake up. Alright, so it's like a timer, so to speak. Okay, so you have two methods to design your stuff. Alright, so just think that lah, okay? But please take note that there is a delay after the wake up signal has been detected. Alright, so to allow the time for the clock oscillator to stabilize. Alright, for the SAM, a deeper sleep, alright, for the SAM is a type of microcontroller also. Alright, a deeper sleep backup mode gives a longer delay. Okay, so what does this delay mean and things like that? Is that, for example, if you happen that you sleep, alright, you sleep inside your bed, okay, and somebody wake you up, alright, you require a little time to actually wake up, right? So along maybe about 2 minutes, 3 minutes, then you wake up, then you feel a bit tired also lah, but at least you wake up. So you need a certain delay to wake up. Alright, so that's the meaning of waking up your system. But in terms of the system, alright, the oscillator, it means it talks about the clock oscillator to stabilize. Alright, so I would assume that at first the main clock oscillator is sleeping. Alright, so in order to wake it up, you need a certain time. Because when you power up the system, you may need a little time to actually power up smoothly, and eventually it will run smoothly. So this particular time is the delay time, or we call this the transient time. Alright, I'll be wrong lah, but at least something for you to memorize better. Alright, so you require a certain delay to actually allows you to wake up. Alright, so you need a certain time to fully wake up. Alright, so if you have a deeper sleep, alright, then you requires a longer delay. Alright, that's just the meaning, so you just take it lah, okay? The purpose of this delay is because it's trying to retrieve back all the informations before it sleep. Alright, so before it sleep, you have many information, like maybe 1000 data. Alright, so after that, when you wake up, alright, the next time you wake up, you also need to retrieve back all this 1000 data. Alright, so you need a little bit time to retrieve all the data before you can fully continue to work. Alright, things like that. Okay, that's just the meaning of what they're trying to say lah. Alright, so the microcontroller may then simply pick up from where it had gone to sleep. So this thing tells you that there is a lot of data. Alright, so the microcontroller will take this time to pick up whatever thing that is left behind before it went to sleep. Alright, these are the data. Alright, or nonetheless, you may also reset and start at the beginning again. So you reset everything and then you start your microcontroller again. But it's important when you check whether your microcontroller is starting after the power was first turned on. So you need to see whether is your microcontroller still working lah. If it's not working, then if forever cannot wake up already lah. Alright, buy a new one, I think. Yeah. But anyway, so the low current drawn while asleep means that there is no need for an on-off switch. Alright, so most modern electronics is partly on at all times. Alright, so normally you just hibernate now. So the low current drawn while asleep is really very low. So therefore you don't even need an on-off switch because of the issues of retaining the RAM data. If you still remember, there is a RAM data. Alright, because the RAM data are all volatile. Once you off the power, all the RAM information will be gone. Okay, so therefore if you don't want to lose your RAM data, alright, you want it to be always there, then you can actually don't off your computer. But as time goes by, your RAM data is going to increase. Right, it's going to increase because there's a lot of data going on, and this is why normally when you didn't off your computer for really long time, your computer will going to be lagging. Alright, because it's having a lot of RAM data going on. It's taking up a lot of RAM space. Alright, so you need to restart and then refresh all the RAM so that there will be no, yeah, it all depends whether you want the RAM data or not lah, things like that. Okay, less most modern electronics is partly on all times. Alright, because I don't know, think about it. And then lastly, there are different strategies to help you save power. Okay, so nonetheless you can use a slow clock. Alright, a slow clock means that it is a current is equals to 1 over the clock frequency plus a certain constant value. Okay, so for example, you have a 60 milliamp, alright, at a 125 kilohertz. Alright, in other words, the higher your clock frequency, alright, the lesser the current it is. Alright, because 1 over a very big number, for example 1 over 1000, you have 0.001. Okay, so over here, if you see, at first you have a 125 kilohertz. If you have this amount of frequency, your current is about 60 milliampere. Okay, and in fact I don't even know how the math works, because there is a certain constant value gonna affect your clock frequency. Okay, that because clock frequency plus a certain current, 1 over your clock frequency plus a certain current will give you plus a certain constant, a certain number will give you a current. Alright, so although the higher your clock frequency it is, you may have a high constant also, but nonetheless, if you run at a 84 megahertz, alright, the consumption of your ampere is only 80 milliamp. It's still okay. So the higher frequency you run, alright, you are still taking in quite a fairly less amount of current. Okay, things like that. I don't know what to say lah, but but you just need to know that use a slow clock will do. Okay, and that so a slow clock is used whenever you have things that is not required, or these things are running in a slow pace, or you don't even need the clock itself to run. Alright, so sometimes you may have a certain processes that requires a clock to help you calculate things. Alright, so therefore a clock is needed, but you can have a slow clock so that you don't take in a lot of current. Alright, things like that lah. Okay, just memorize lah. Okay, so this is one way to determine, or one way to help you save power. Alright, so nonetheless you can switch between fast and slow clocks, alright, to save power. So if you want to use certain things already, then you increase the speed. Otherwise you leave it as a slow clock. Okay, the next method is to turn off all peripherals, meaning devices that is not related to your output. Alright, so they are not needed. Okay, for example, your analog to digital converter, alright, is on, but it can be switched off when you're not in use, because you don't even use, if you are doing certain output, you don't even need to convert the analog to digital, because the output is from digital to analog, is DAC. So when you are using DAC, why do you on the ADC for what? So these are the things that you may want to consider when you want to save power. Okay, and then ensure that all inputs are driven or connected to VSS or v10e. Alright, I don't know why, how can this save power, but you just memorize. So don't forget internal pull up. Alright, if you don't know anything about the internal pull up, then I can't help you lah. I don't know where to start also. I've been through quite a lot of pull-ups talking about it already, so yeah. Fourth one is to put the processor to sleep whenever it's possible, and then use modern components designed for lower supply voltages. So if you're talking about lower supply voltages, then you want to have you want something. If your application is lower supply voltages, then you're gonna source for certain components that is compatible with lower supply voltages. If you're using high supply voltages, then you're gonna find for components that can help you to save power when you're using high supply voltages and things like that. Right, so these are the 5 things that you may want to also know for your strategies to save power. Although I explain it with a very lousy way of explanations because I suck. But anyway, yeah. So this is the things. So in the next video, we'll talk about how powerful is this the concept of sleep. All right, help you to save power. How well can it be so that you can save a lot of power? So we're gonna use certain examples to explain to you these things. See you there.